Here we just kind of want to get practice with all these rules that we've been looking at. And specifically, it looks like we're going to do with the negative exponents and the fractional exponents. So this one right here, we're just looking at just quickly finding the cube root of negative 27. So it's like, what do I have to multiply 3 times to get negative 27? Well, 3 times 3 times 3 is positive 27. So if I go negative 3 times negative 3 times negative 3, then I'll get the negative 27. And as if you just want to write yourself just a quick little note, if this was the square root of negative 4, remember we can't ever take a square root of a negative number, so what you might want to say is just undefined. Some of you guys are fluent with imaginary numbers. You were exposed to those in high school or wherever your last math class was. Don't worry about that. We're not going to do imaginary numbers in this class. So what I just wanted to show you is if this index number right here, or which is also known as the type of root, if it's odd, it doesn't matter what's underneath it. It could be positive or negative. However, if this index number like here, the square root, is even, like a square root, a fourth root, a sixth root, everything underneath it has to be positive. You can't ever take a square root of a negative number. Okay? Let's go to this next part. It's saying we have a fractional exponent, so right away I'm thinking fractional exponent's got to do a radical. So it's the 5th root of 32. And now I can either square 32 first, but looking like it's going to be a lot easier if I save the squaring to the second step. All right, so now what number do I have to multiply 5 times to get 32? Well, 2 times 2 is 4, times 2 is 8, and 16 and 32. So it looks like it's 2 to the 5th. All right, so the 5th root of 32 is 2. Clean that up, so now I'm going to bring in the squaring, and 2 squared is 4. And there's your answer. All right, let's go to the next part. Again, a fractional exponent, so to clean this up, I'm going to convert it to a radical. The bottom number's to 2, so we're talking about a square root. What's underneath it will be the base, so 9/25. And then after I'm done taking that square root, I'm going to cube it, because that's what that top number tells me, is that exponent afterwards. I've got a cube. So the square root of 9/25, if you have a fraction underneath the radical, just take it part by part. Square root of 9 is 3. The square root of 25 is 5. So if I cube it, then let's go piece by piece. It's just 3 cubed over 5 cubed, 3 times 3 times 3, and 5 times 5 times 5. And there is your overall answer. Okay, now this next one, I have 2 things going on here that we've got to watch out for. One, I've got a fractional exponent, so I've got to do a radical. But 2, it's a negative exponent. So I'm going to handle the negative part first. I want to make it a positive 2/3. So to make it a positive 2/3, I'm just going to go to that base and write it as a fraction. Okay? Or take the reciprocal of the base. Simple as that. All right, now let's go to the radical part. So I have the cube root of 1/8, and then once I'm done with that, I want to square it. So what number do you multiply 3 times to get 1? Or what's the cube root of 1? 1. What number do you multiply 3 times to get 8? Well, it's 2, because 2 times 2 times 2. So the cube root of 1/8 is just 1/2. Just take it piece by piece, just like I did. And now we want to square it. So 1 squared is 1, 2 squared is 4, and there's my answer. It's 1/4. So 8 to a negative 2/3 power is 1/4. So it's definitely shrinking it, as you can tell. I started out with an 8, then I raised it to this negative power, and it dropped it all the way down to a 1/4. Plus I incorporated a radical, so that changed it a little bit too. All right, let's go one more before we go to example 7. I've got 2 things here. I've got a negative out front, actually 3 things. I've got a negative out front, I've got a negative exponent, and then I have a fractional exponent. So let's do first things first. How about we take care of this negative up here in this exponent? To make that positive, all I'm going to do is take the reciprocal of my base. Okay. And notice your base is not really this negative out front. The base is what's in parentheses, because that's what's to the power. The base is 27/8. So if I'm just going to take the reciprocal of that base and write it as 8/27. Okay. And again, now we're going to write a radical. So it's the cube root. Okay. Question, do we incorporate the negative inside that cube root, or do we throw it out front? Well, here's your answer, is what really is to this power. What's to the power is only what's sitting here in these parentheses. So the minus has got to stay out front, And we'll write 8 over 27, and then all of that, to the first power, which really won't do much. So the cube root of 8 is 2, and the cube root of 27 is 3, and there's our answer, just like that. All right, let's go a little bit further into this to example number 7. Okay, so we're kind of just taking it a step above into the next level, and we want to simplify the following when just write our answer only with positive exponents. Okay, well, before I start changing these to radicals or anything like that, first of all I notice is the fact of we have 2 to raise to a power and 2 raised to a power. So I'm going to use property 1. Property 1 says that if I have the same base raised to 2 powers and I'm multiplying, then I can keep that common base and just add my exponents. So it's saying 6/5 plus a negative 1/5. So I want to do that first because it's like, why convert each of them separately and then try to clean it up when we can combine these together first and then we can go about cleaning it up. Make our life so much more simpler. And I want to reiterate the fact of the base is still staying a 2. It's not a 4. When you have, that property says is that when you have a common base, you keep the common base and then you just add your exponents. Okay? So keeping that common base again of a 2, 6/5 plus a negative 1/5, or 6/5 minus 1/5, is 5 over 5. So this is just 2 to the first. Simple as that. And look, by us combining it first, we didn't have to worry at all about negative exponents, really. We didn't have to worry about radicals or anything like that. So definitely to our benefit. Okay, let's go on to this next one. It looks here. I've got one big fraction. I've got some negative exponents in the top and some negative exponents in the bottom. So I could do one of two things. I could rearrange them, move some terms around, or we could, if I have a negative exponent in the bottom, I could just move this whole term up to the top, and that actually will make that exponent positive. And I could do the same thing with that one and move it down. Or if I want to go to my rules, and basically says the rules, that second one, is if I have common bases and they're in a fraction, I keep the common base and I subtract my exponents. So I'll take that first exponent minus my second exponent. I'm going to go ahead and do multiply because they're all multiplied together. The next common base are 3's. So I'm going to keep that common base, take that top exponent, and subtract the bottom exponent, making sure I do those double negatives in there. So it looks like we already have common denominators on that first exponent. So a negative 1 minus 3 would be a negative 4 over 2. And on the 3's, that's just 2/3 plus 1/3. So 2 plus 1 would be 3 over 3. All right, so cleaning this up a little bit more, we have 2 to the negative 2 and then times 3 to the first. All right, I've got two options here. If I want to make that exponent on that first one positive, just take the reciprocal of the base. So 1/2 now squared because it made that exponent positive, and then obviously times 3 to the first. Well, 1/2 squared is 1/4, and 1/4 times 3 would be just 3/4. And there's your answer. Okay, let's try this next one. I have things just here inside this base. I've got lots of stuff going on here in the base, and overall it's being raised to this negative 2/3 power. Okay. Well, we can do one of two things. You want to just clean this base up first of all? And what I see here is, when I look in this base, is the fact that we have, let's try this negative x to the negative 6. Notice how it's negative 27 times x to the negative 6. There's two separate things happening here in the denominator. You've got this number, and then you've got x raised to a power. Well, if I want to make this x positive, what I can do is just take this part of that term and move it up. Okay, so that's really going to be now x cubed times x to the 6, because I moved it up, now it's positive, and what's staying in the base is the negative 27. Now, I'm going to take 2 seconds and tell you guys, remember, we only move things that have negative exponents. We don't move things just because they're negative. Like that 27, it's negative, but it doesn't have a negative exponent. You only move things that have negative exponents, not negative signs, okay? So cleaning this up, x cubed and x to the 6th, same base multiplied, so we're going to add. Okay, and that's really what's happening now to the negative 2/3 power. Well, let's go to this outside power. If I want to make that positive, let's take the reciprocal of the base. So the negative 27 is moving up top, the x to the 9th is moving down below, and by taking that reciprocal, it now makes that exponent a 2/3. All right. Well, one higher exponent on the outside. Let me get us some more room here a second. I have one higher power on the outside. Let's raise that to both parts. So we have a negative 27 is being raised to the 2/3, and then we have an x to the 9th being raised to the 2/3. Okay. Well, I'm going to do this top because the base is just a whole number. It's just a regular number, not a variable. Let's go ahead and take this 2/3 exponent and write it as a radical. And that's as a rule of thumb, by the way, is if your base is a number, go ahead and put it into the radical form and try to clean it up. If your base was a variable, then you don't really have to worry about converting it to a radical. Just leave it as a fractional exponent. Okay, so this is saying a cube root of negative 27, and then we're going to square our answer. Whereas down here, like I said, the base in this case is a variable, so all I'm going to do is my rule of exponents. If I have one base that's raised and re-raised, remember that means, it just means multiply. So 9 times 2 is 18 over 3. Okay, the cube root of negative 27 is negative 3, and we're going to square it. And 18 divided by 3 is 6. So finishing this up with the very, very last, negative 3 squared is a positive 9, and then x to the 6 in the bottom, and there's our overall answer. Okay, so there's definitely a lot to this one. And I just kind of want to, just more than anything, just kind of walk you back through this just one more time. And we could have done several things with this one. Let me go back to this original part of this problem. If, like what I did is I chose to clean up my base first and then bring in that exponent. If you wanted to, you could have brought in this exponent first by, multiplying it to the existing exponents and then gone about it that way. You would have gotten the same answer. It's really on when you start this problem out is how you see it. And a lot of times what people ask me is, why when let's say you have x squared over 2x to the negative 1. And what a lot of times what people ask me is when I want to move this variable up so it becomes positive, why don't I take the 2 with it? Why is it just x squared then times x to the first, but the 2 stays in the bottom? And the whole thing is, I just want to reiterate to you guys, is there's really a big product happening in there. Okay, so when I go through and I want to just move terms around, you only can take parts of the product at a time. If that base instead, let's say if I wrote it like this, erase that right there. If I decided the only way I can move both of them is if it said 2x like that to the negative 1. In that case, then I would have x squared, and then it would be 2x to the first and nothing left in the bottom other than 1. Okay, so if you don't see that parentheses, you've got to really analyze you have to see what truly has that negative exponent. If it's just on a variable, well, guess what? It's just the variable that has it. Okay, let's try one more of these before we go on to example 8.